like it's been forever since I done these. Alright then, boys and girls. I don't know why I clicked my fingers. Alright, boys and girls. Last time we did polynomials, so this time we're going to kind of start going through them. But you see, these constant and binomials are quite simple and quite kind of, well, boring, alright? But I want to just mention them before we move on to quadratics. So this should be only a quick video just to make sure that everyone's on the same train of thought before we go looking at quadratics. So, what does a binomial look like? Why is none of this in the right position? Maybe it used to be back more. Alright then, so we've got constants and binomials. When we actually have a constant, it's something that looks a little bit like y equals 3, for example. This is just y is 3. Every single value of x that we could ever have, y is just 3. It's always just 3. So when you graph this, as in when we want to visually look at 3, we compare y, which is 3, to x. So if we put in all these values of x, we're still going to get 3. So let's think about what that looks like. Here's our coordinate system. It's a Cartesian coordinate system, meaning that you've got x and y and they're at right angles to each other. That's pretty much all you ever use in A-level. So if you've got y equals 3, then y is 3 everywhere. I know I've said that a million times, but it's just that value of the constant. If we put in x is 2 or something, then we go in and go up, it's 3. If we put x is minus 2, we go in and up, it's 3. That's all it is. That's why it's a constant. Now the next one is actually where we've got some variation with x. So ax plus b. Usually we'll think of this as like mx plus c. So if we've got, let's say it's y equals x plus 3. Now what we've got is coordinate system. This is I'm fucking sick of this. Right, so the thing that was going on there was that, well, like everything in here was bothering me. I've had some rearranging done again, got some new lights, and see the thing about that content I was doing was this kind of, you know, the constant graphs and the binomial graphs, it's kind of really easy, and so it's kind of really boring. So what I want to do though is I do want to cover it, but I'm going to mention this thing called Desmos at the same time, and we're just going to look at the graphs there. We just need to look at them essentially. So Desmos, if you've not come across it, is like a graphing software that you can go on a browser, or you could install the Desmos app, and bada bing bada boom, here it is. So right here, that's what we're gonna do. So rather than make everything from scratch, I'm going to go here, click that, and what you have there is our binomial. Now if I add in the slider, then changing the gradient, that's like your mx plus c that we're familiar with, and then changing that intercept, the y-intercept, that's the little bit at the end. So the x coefficient is the gradient, that's how many it goes up or down when you go across one. So if I've got it as a negative number, you go across one, your y changes by minus 0.4. Easy as that. Let's just turn that off. You can really see the y-intercept if we write a little coordinate. If we do 0, which is our x coordinate, and if we change b, we'll see that that is moving up and down as we'd expect. You know, it's what we expect it to do. So let's just move. We'll move this down here. And the nice thing about Desmos is that you can make it all nice and neat. We're going to make a new expression, and this expression is going to be our constant. So y is any number. So y equals, let's just say 3 Bam, done. It's added a little slider so we can change that around. As you'll see is that y is 3 everywhere, so it doesn't matter what value of x. This is what I was saying in the video. It's always, stop that. It's always just that number. It's a straight line, so the gradient of this is 0. It's just a straight horizontal line, so the gradient is 0. And you can kind of imagine that by thinking that the coefficient on the x, if it had an x, would be 0, so then the gradient is 0. That's why it's not there. But that's a horizontal line. What if we had a vertical line? Let's just throw one of those in. We could do the little coordinate thing as well, but I'm not going to bother. Let's say equals 5. Okay, done. Get rid of that. Yeah, okay. So then I'm going to move that left and right a bit. Let's just zoom in. So that's going to move left and right like that. So the gradient of this though is actually infinite because it goes straight up. That's like because these two lines are perpendicular. So you've got one is 0, then the perpendicular gradient of that line is -1 over that 0, which is infinite. So that's why it goes straight up, because as it goes across one, it's gone infinite. That's it, like simple as. I don't like that colour. Let's change it to purple. That's it. What we're going to move on to after this is quadratics. So that's ones where it's like y equals x squared. That's what we're moving on to next. Now these ones, after your binomials, you can't just read the gradient straight off of this graph. You have to use some special techniques. But before we get to those special techniques, which is differentiation by the way, we're going to have to learn how to solve these quadratics. And to solve it, what we're essentially doing is, when does this quadratic equal 0? So if this was -3, what you'll see here is that at some point there and there, this quadratic goes through y equals 0. And that's what we'll be looking at next time. Right? We're back on track. Whew. Good stuff. I'm going to press stop on there.